There we go. Okay. 12th meeting, lesson 12, or 11th meeting, lesson 12. All right, let's start it.
Okay. Do you have your quiz up? I have the quiz up, but I can't pull up the Okay. I don't know the equation first. I don't think you, so we have a set of I don't think we're using the data files for the first one. Yeah, I was like, so when the standard deviation isn't known.
So I wasn't here for the last meeting,
Mm-hmm.
but so the symbol S with the little D next to it, is that standard deviation or is that something different?
It's standard deviation.
Is
Okay.
it? Because it says, and the population standard deviation with the alpha.
Oh no, the standard deviation is not known.
Yeah.
So what does the SD mean?
The SD, when you like plug it into
The little Excel thing.
it is the standard deviation, but it's for the goal.
Oh,
Like sets of data.
I see.
So for like one set of data, it's not known, and the other one is not known, and you do it together. That's the standard deviation.
Is it the standard error of the mean? Is that different? Oh, it might be. Okay. So the equation for the test statistic.
So for the what exactly is the value that we're looking for? Like, what are we supposed to plug it into the student's T probabilities applet and then find T? Is that what we're trying to do?
I think so.
I
I think like data A is for like one set, and then data B is for the second one, and then that's how we get all the equals.
okay.
I couldn't quite hear that.
She said data A is for one set and data B is for another set, and then we just put it in for our test. Is it a paired data? Okay, you're right. So a paired sample T test. Well, the only problem is chapter 12 data A has two groups in itself. Like, it's not like one group and another group. Wait, let's look further down in our quiz. Yeah, because question number 5 is asking to use data set A, so we don't need a certain data set for this one, I'm pretty sure. There's just a dumb equation, but it's
But how do we like know the mean and everything?
D
We don't
with
have the means of all of that.
oh, it's what it is. Is it
Would it be 2.2 minus 0? 3 divided by 3.3 divided by square root of 9?
Was anyone what this question was asking?
So the equation is like T equals like the second mean, I guess.
minus
the
0?
mean, 0 over S, 3.3 divided by N would be 9. So I'm pretty sure that's like
Oh, I think okay.
So what is the actual equation? Like T equals what over what? You know?
It would be
like the line over the X.
well, it's the D with the line over it minus the mean
Oh, is it the D with the line?
Yeah, over the SD divided by the square root of n.
Oh, yeah, you're right.
Okay.
And then from there, you should be able to do that equation. So it's
And so for the mean, are we supposed to put 0?
Yeah.
yeah, because it says in the equation it equals 0 for the null hypothesis.
Right. I got 2.
That's what I got too.
I think that, yeah, that's what I got. All right. So the probability of obtaining a test.
So the probability is the area, correct, in the applet?
I think so. 0.
And the p-value is equal to p? Like what? Sorry?
Oh. Yeah, I think so. How many degrees of freedom?
Isn't it 1 minus the value? So wouldn't it be 1? Or
Greater than. So the value is the same. You like plug in 0.044 right here, and then it says greater than, so it would be 2, right? So it's this, the p value. Oh, it's supposed to put in 0.4, blah, blah, blah.
That's what I'm trying to figure out. The reading doesn't really help.
I'll probably retain the test statistic greater than John's test statistic.
I think you're right. The test you put in the test statistic, right? 403.
Because we put like, we found out that T is 2, so that's what I put. And then area would take into 7. But I don't know, like, what put it in the area or the T, or if we don't even use T.
Is it? I'm not 100%
I
sure.
actually think I probably put the 0.04. And not
So-
the
So if we were to plug in the t or the test statistic being 2 into the applet, and then the degrees of freedom is 8 because it's 1 minus the sample size, which areas do we highlight?
And then you say 0.0403. Would it be? It would be just the top one because it's greater than. And you don't even have to highlight it because it's highlighted for you. I think
Right.
that makes sense because it says my T is 1.999, which is 2, which is what we just calculated.
Right. So
your area is 0.0.
So what is the p-value?
What is this?
Because on mine, I have 8 degrees of freedom. The area is 0.0403, and the t-value is 2. I have everything highlighted from the 2 on.
How'd you get 8 degrees of freedom?
1 minus the sample
1
size.
minus the standard, or the sample size. So what is, like, where do we find the p-value? I don't understand where to see that.
I'm confused too.
P-value is the area to the left of t under the curve. Huh.
Did you read? I read that somewhere actually in the.
That's under, if you go under in the notes,
Oh yeah, it says
in the
the
lesson
p-value
notes,
area
step
to the
4.
left of the t under the curve.
Yeah.
The area is so small.
But it's only to the left because their t-value was negative. So I guess it would be to the right of t because ours is positive. But wouldn't that mean that the p-value is the same as the probability, 0.0403?
Would it be that or would it be 2?
Oh, maybe
We're under 3 decimal
2.
places, so 1.999.
How did you get
Oh.
1.99?
For 1.999.
Yeah, that's what.
Yeah.
In your curve, did you not get that?
No, I just have 2.
Really?
Yeah.
I put 8 degrees of freedom, 0.0403.
Yeah.
My area, and then it highlights the top right portion that says 1.999.
Yeah, like the above 2.
Yeah, it's just like right.
Like the right side highlighted only.
Yeah,
Yeah, mine just says 2.
that's funny.
Mine says 2 also.
Wait, but just 2.000. I don't know why it would tell us around 3 decimals.
Yeah, definitely. I still get 1.999.
I know.
Are we going with 2.000?
Because if we round 3 decimal places and all the 9s would make it round.
But 3 decimals is. I could keep 1.999 and someone can keep
Yeah. So we can keep both of them and just see what happens. Okay. Okay, so we'll try 1.999. So the next one is chapter 12. Use the data to perform empirical tests. Be sure the test is level of significance. Okay. Did it say A? The one equal to the one level of significance. So where I can't here. Okay. So I put it in 1 minus the 2. And then it says, where am I supposed to put the level of significance?
significance. Oh no,
Yeah.
we don't put it in.
Oh,
So
okay.
it's just as soon as for the statistic. So
T is 0.407. Is that what you guys got?
I'm still plugging in the info to the quantitative inference procedures Excel file.
Okay.
So we take the data group 1 and group 2. Is that what we're doing from
Well,
data
data A 1, and it has 2 groups,
Yes.
and then you just put them into variable 1 and 2.
Right. And so doing that, I got T equals 0.407. Is that what you
Yeah,
guys
that's what I got as well.
Okay, cool.
Wait, that's the next.
P-value.
The
Make sure
p-value.
the thing up on the top is not equal to.
Yeah, I have not equal to, null hypothesis is 0, and confidence level says 95. Okay, and then
That's
the
what I got.
p-value is 0.6887. So it'd be, is it 3 decimals? 0.689. Is that what you got?
For what?
P-value, did you get 0.689?
Yeah.
Okay.
Which is the same as the test statistic, correct?
No.
No.
That's not the same?
The test statistic is 0.407.
Oh, it's 0.40. Duh. My bad.
Okay.
Got it. 0.689.
What is the correct decision based on this evidence? So the
Failed to
is this high?
Fail to reject the name?
Oh yeah. Fail to reject.
Isn't it if the p-value is small, we reject it? Is that how it is?
yeah, but the p-value is
High,
greater than
fail to reject it. Okay. Suppose your alternative hypothesis instead. Okay, so should I change that into the thing
So we change it to greater than?
greater? Yeah. And then
The p-value went down.
the p-value went down to 0.344, which is still greater. So we have insufficient. I always get it mixed up, so I need to write it down. P is high.
So would it be we have sufficient evidence that the mean difference is greater than 0?
Fail to reject. We have sufficient evidence, right? Oh, I always get this messed up. Why can't I get it?
So let me write it down too, because I mix it up too.
I know, I'm sick of
So if we fail to reject, we have sufficient evidence.
to support.
Is that correct?
That's what sounds correct to me, but
so we can put it. So we reject the null hypothesis because there's sufficient evidence that the mean of the difference is greater than 0.
wait,
But we failed to reject it.
yeah, because I thought the p-value is high. Because you choose fail to reject or reject before you choose.
Fail to reject.
Okay, so if you reject sufficient evidence to say, so fail to reject insufficient evidence. I think.
Greater than 0?
So the second option, insufficient evidence that the mean of the differences is greater than 0.
Well, but we're going based off of the null hypothesis, not the alternative.
Not the one that's in question 8, because it says
Yeah.
suppose your alternative hypothesis is instead greater than 0.
But our null.
Oh, it's based off the null, not the alternative. Okay, so it'd be the first one
And why is that?
because it's based off of the null, not the alternative hypothesis. And the null says equal to, and the alternative said greater than.
So we have insufficient evidence that the
Yeah.
differences are equal to 0 because it says it's greater. It says that it's greater than.
Mm-hmm. Okay, let me get Yeah.
Can you guys run that by me one more time? I still don't quite follow it.
Yeah, do you want to say it?
Sure.
Closer.
So you have to like base your test off of the null hypothesis always. Like even
Which
though
is
we
0.
prove, right, that it's equal to 0. So even though we prove that the alternative hypothesis is correct, we can't base our information off of that hypothesis. Does that make sense?
Kinda, yeah.
So you always have to look at the null hypothesis. So it says that the mean is equal to 0. And we failed to reject that. So we have, so we failed to reject, so then we have insufficient evidence that,
Okay, well, I googled it,
if we
and
fail,
this statement says it's just talking about a specific example, and it says you reject the null hypothesis, and you say sufficient evidence to say the patient is dead. You fail to reject the null hypothesis, you say insufficient evidence to say the patient is dead.
Okay, so we're going with the first one because we failed to reject it, so we have insufficient evidence. And we don't have enough evidence saying that it's equal to 0. Why is it not greater than 0? So why wouldn't it be the second option?
Because the null says equal to.
Okay.
That's what the null is.
Okay.
saying.
Okay. That's fine.
Yeah,
Thank you very much.
there are multiple things on Google to say. It sounds backwards.
I know.
Okay, I have the next one up. Okay. If we greater N or the N is greater. N is 22 and DF is 21.
That's
Is that
what
what you
I
got too?
Yes.
Mm-hmm. If we're wrong on that one.
Did we switch the data point? Because this is for the B one.
Yeah, I put B data in. Oh wait. I need to say it's not equal to. That shouldn't do much.
That just changed the P value.
Yeah, I just wanted to change that before I forgot. Okay.
So N is
P-value.
greater, and then question 10, the p-value is 0.001.
0.0. Yeah.
Yep.
0.001.
Yes. So because that's a very small p-value, we're going to reject the null hypothesis.
Mm-hmm. And then let's see what the p-value does when I say greater than.
It's still small. It got
But it
extra
goes-
smaller.
It gets smaller.
So decrease.
I like how a lot of
What
these
did you
have
say?
swapped, so if we're wrong, we're like, oh, it's
Like,
yeah, they're right.
Yeah. What decision do you make? You still reject it, right?
Yeah.
Because it's small.
Mm-hmm. Based on your response, so we have sufficient evidence that there. Oh, but I don't know if there is.
We have sufficient evidence. There's a different decision.
Real
Okay,
quick, what did you say after 10?
What?
There's sufficient evidence So there's no mean difference.
What did you get for question 10 as the result?
Question 10,
Yeah,
0.001.
okay. I thought you said there was one less 0. No problem.
So because we rejected it, we have sufficient evidence.
Yeah, we're just trying
But
to decide.
how do we tell that there is or isn't a mean difference between the two groups?
That's what I'm not sure. I think that there is a mean difference.
Because we're rejecting that n equals 0. So that means we have sufficient evidence to suggest that there is a mean difference between the two groups. Right?
Yeah, I'd go with that.
Well, I don't know if this is correct, but if we look at the table for variable 1 and variable 2, you can look at the means and see that they have the difference, 11.955. I don't know if that is exactly how to do it, but we can tell right there that there is a difference. So I would say that there is mean difference between the two groups just because of that data.
With what she's saying, so I'd go with that.
Is that what Kayla was saying?
Yeah.
Okay, so we're going with the third option, even though there's a typo.
Yeah.
Typo? I didn't even know
It says between the two group.
There is a mean difference between the two groups. Oh.
Oh,
Yeah, I think it's
I think
still
it's-
fine.
okay.
Defeated by the alternative hypothesis in general, which alternative hypothesis would give the smallest p-value? When yeah, okay. So
When it's greater than 0?
I think that would be the case, but I'm gonna double check them all.
Sure.
Yeah, it's greater than 0. Because if I do less than, it's almost 1. So,
Okay.
so what's the point estimate? Oh, I always screw this up.
So when
95
it says using group 1 minus group 2, what does that mean? To find like the difference, or what exactly does that mean? Excuse me.
I wonder if that just means like with the data given in Excel, having group 1 be variable 1 and group 2 being variable 2. So all the information matches with that rather than be group 2 as variable 1.
So how do we find point estimate?
Isn't with 2 groups. I don't know how to do it with 1 group.
Oh, but this was the means.
Because the point estimate is that less than 11?
It is. That's why I don't know about it.
Yeah, yeah, it's actually better. Way less than 10.
That's less than 10?
Yeah, 3.1 is point estimate.
Just this point estimate equals like far thing.
What?
Is that like the 1.96 thing?
Yeah, that's what I think, but I don't know how to do it with 2 groups.
It says in lesson 12
Because it.
here.
What?
under section 4 in the lesson, talks about how to
Uh-huh.
find the confidence interval.
Oh, confidence interval for what? Confidence interval is actually a point estimate x over. You're right. I think it is x with the bar, but um, is that when you have the do you think that's given in Excel? Because you want the point estimate, margin of error, lower and upper bounds. I feel like those are given. That's the X with a bar over it.
Does anyone know how to do it? I'm still kind of lost.
Oh, yeah, because that's where you have to like go from.
Is that the standard error of the mean? Is that because you take the point estimate is like, so you take the mean and then you add it and you get the upper and the lower bound, right?
From that value.
What?
So is that the main exercise? And the standard deviations of from the.
I don't know. We're on the right track though. Because no, I think it is the mean. Because look, you have on this one right here, you had point estimate. X with a bar is 65.4, and then over here, I did 65.4 plus the standard deviations.
And then
So-
the upper and lower.
Do you think it would be the mean would be the 11.955? That's the differences mean.
The one that's like right here.
Yeah.
It's not the right step.
Yeah. No, but I know what you mean. So that you think that would be
I
it,
think so, because that's the one that you're gonna base it off to find the upper.
and then you take the standard deviation and add it. We can try that. So it's 11.955, and the standard deviation of the means of the two is 15.003. So we'd have to add and subtract that.
So for 16, it's 11.155.
16 is, I think so. Hopefully.
But wouldn't it be because it has a difference of 2 being the 95% confidence interval? So when you have to multiply it by 2,
I don't think that's James.
I don't think you have to because Excel gave me that value.
so what's the equation?
It's the mean of the value, the mean difference of the values. I'm pretty sure. I got it off of the Excel, the quantitative inference procedures. I didn't calculate.
So you're saying the answer is just the 11.955 because that's the difference between the means?
That's what we're thinking. It's the that's the difference between the means. It's not like a mean. Do you think that would be a mean? It's a mean. It's the difference of a mean. I don't know.
Well, that's the median of the means, I guess you could say,
Yeah.
because that's just in between them.
Yeah, we could try it. We'll try it. So 11.955, then plus or minus the 15.003.
Why do you, why do you plus or minus the standard deviation?
To get your upper and, well, I'm saying that's for the upper and lower bounds, the next few questions.
Oh,
Oh, wait. That's the margin of error.
well, 18 and 19 are the upper and lower bounds. But since it's a 95% confidence interval, wouldn't it be the mean plus or minus 2 times the standard deviation? Because it's 95%. If it was the 68%, then it would just be the mean minus or plus the standard deviation.
Find out what?
Well, I know what you're saying.
Because it gives you the lower and upper,
Well-
right?
What? This isn't giving me a...
Oh, it doesn't.
Oh, it does. Wait a minute.
Yeah, because
The
it's
confidence interval.
yeah, that's what it is.
Why 5.303? And then 18.607.
What's the standard deviation?
15 of the mean. So you could find the difference between the two and divide. Hold on. 18.607 minus 5.303 is 13. And then you divide that by 2, and it's 6.6. Dude, that value is nowhere on my. Oh. Oh, wait. 6.652. Okay, wait. Actually, I take that back. Minus 18.607. No, that's right. It is 11. I calculated it from the confidence interval.
So then the lower bound is
The margin of error, is that just the standard error of the means difference value?
I always get this one wrong. I don't know how.
Oh, yeah. I'm gonna ignore that for a second because I'm gonna tell everyone that the upper and lower bounds. The lower bound is 5.303, and then the upper bound is 18.607. Oh, that is nice.
How come those are the upper and lower bounds? Like, I know it shows it in the confidence interval, but how do we know that that's upper and lower?
So actually, I just calculated it to make sure. So I took that mean. So I took the difference between the two numbers, and then I took that number, which was like 13 point something, and then I divided it by 2, because that tells you the distance you took from the mean from one of those numbers. So I did 18 minus 6 point whatever, and it gave me 11.955. So that was saying that standard deviation from the mean 11.955 gave you the upper bound, and then if you subtract from the mean, you get the lower bound.
Okay. So what's the margin of error?
That's what I don't know.
I always get this stupid.
I know. I'm like, we couldn't figure it out last time, and I.
Okay, well, I have an equation. It says margin of error equals like depends on if it's 90, 95, or 99%. So just like z or whatever times the standard deviation over the square root of n.
Z times the standard deviation, what?
Over the square root of n. So for this one, it would be 1.96 because that's what it was used for.
Oh, I have that thing right here too.
1.96 times, but what the standard deviation I think would be the one that
15 point. Oh,
the one I don't know.
the one that I was calculating.
Yeah.
I can tell you that 11.955. It's 6.652.
Because all you have to do is like the 1.96 times the standard deviation, which obviously is this number, divided by the square root of this.
Square root of 22. But the only thing that is weirding me out is that the standard deviation difference right there isn't the same. It's just
Okay, hold on. I'm gonna find something. The mean. So that'd be 7.969.
But the standard deviation that's given doesn't match up with the standard deviation I used to get the two confidence intervals. Because it's 11.955, and you wouldn't add 15. Subtract 15. It was like that 6. 7.7. I'm going to try the 6 point something.
Well, I got 6.269.
Really? Wait, what? I got 2.77.
I'm just gonna try this one. I don't think it's right.
I'm gonna, I did 2.780 for my margin of error because I tried the standard deviation I calculated rather than the standard deviation that's shown. I'm gonna turn it in because I have to go soon, but I'll see what happens.
All right.
Let's see.
So
How many?
we
Crud
got
Ola.
question. We got question 4 wrong.
Yeah.
It's a lot.
We got question
Gotta be.
8
Question
wrong.
4 is wrong. Wait, did you put 2.0 for your number 4? Oh,
Yeah.
come back.
Well, I
You
put
put 2?
2.000.
I put 1.999 and that was wrong too.
Wait, did we turn it in?
Yeah, I think we're us with it.
You got it wrong.
Yeah.
So which ones are wrong?
Number 4,
Number 8.
number 8.
Number 15.
148.
Yeah, we have a few more though, but I'm just showing you pictures of them.
We got 15 wrong.
Yes.
I wonder if it would be not enough information then.
And also number 16, unless I wrote that wrong. Was 16 1.96?
16 was no. 11.955. That one's right. 17's wrong.
I got
But
that right.
You got 17 right?
Yeah, it was 6.652.
Oh, that's the.
How did
That's
you get
margin
that?
of error. I calculated 6.6. Son of a gun.
How did you get 6.652?
I can tell you actually now. So you take the standard deviation
Which is
between the standard deviation and the upper or lower bound. So you take the upper and lower bound difference, which was like 13 point something.
yeah.
You divide that number by 2, which is 6.652. And then you take 11 plus
Hold on,
6.652.
Hold on. So 18.607 minus 5.303,
Mm-hmm.
and I get 13.304. What is that value then?
That's just the difference between the upper and lower bound, and then you have to divide that by 2,
Divided by 2.
and that gives you 6.652.
Which is the margin.
Okay, which is the margin of error.
Yeah, and you take the mean and you add the margin of error to get your upper and lower bounds. Okay. I'm gonna finish.
Number 4, number 8.
Yeah, so number 4, number 8,
And 15.
15, and then I got 17 wrong, but you guys have it already, and that's it. And so I have to go, but I think those ones are easy to figure out. I'm just glad we got that stupid margin of error. It was just that simple. I'm like, we had it.
We're like thinking about it.
Oh no, wait, I have it on mine. So I'm gonna turn mine off, but you want to turn your sound on so you can keep talking to them.
Sure. Are you guys gonna be working on it?
Are you guys gonna stay on? Because I'm going, but
Yeah, I'm gonna stay on for just a little bit longer.
okay. Do you want to turn? Yeah, I'm gonna end mine.
All right. Did you want to go over 4, 8, and 15, Russell?
Yeah. Let's see what we can do.
Okay. So for 15, p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value? If it's not greater than, I'd say there's not enough information because maybe the alternative hypothesis is a really high number or something. I don't know.
Yeah, that's what I was thinking too, because it does depend on what you set it as.
Right.
So if it's not
So
giving us that information, then kind of bunk.
Yeah, so I'll do that, and then I'll submit it after we do 8 and 4, and see if it's right.
Okay, cool.
So for question 8, it's not the first option. So I'm guessing it's probably the second option, just because since we failed to reject the null hypothesis, we have the insufficient evidence.
My computer is freezing. No.
I'll go with that one as well. And question 4, the probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. Use this probability to determine the p-value. Ay, ay, ay. Well,
This is probably the most confusing section that we've done.
it is.
I just like it. Come on, computer.
Oh, I'm not sure if Kaylin wanted to stay on. I think she. I'll invite her, see if she wants to come back in. T value is 2.
So here's my question. How do you determine the p-value?
You're gonna have to repeat. I could only hear about half of what you said.
Yeah. No problem. I was saying, how do you determine the p-value?
I don't know. I was trying to look in the lesson notes or whatever, and it shows in step 4. They did the QQ plot of difference or whatever. And then under that, they found the degrees of freedom, and under that, so after they found the test statistic, they plugged that in for T in the app, like we did, and then it just said it says find the p-value and compare it to the level of significance, and the p-value that they got was really, really small. And so I think the p-value is the area. But if we're to do the area where the t-value we got was 2, right? So I plugged that into the app, and we have 8 degrees of freedom because the sample size was 9. The area I get is 0.0403. It's the same as the probability. So I can try that, see if it's right, and let you know.
Give that a ring.
Okay. No, I missed some. Hold on. No, it's not right.
The p-value is the area of the rectangle.
But all of my other answers are right. Just that one was wrong.
Alright. To be frank, I have a headache and I've had enough of this.
Yeah, and I gotta go too, so let's call it a day.
Yeah.
Thanks for the help though. Appreciate it.
Yeah, no problem.
All right. Well, we'll see you on Wednesday. I guess the same time. Just what time do we meet on Wednesday? Is that the one? That's the one where we meet at 2, right?
Yeah, we meet at 2:15, I think.
I'll be in the comments then. So
Cool. Me too.
see you later.